Hey guys, welcome, Jen from Scholarly here. This video will just be an explanation and breakdown of the 2022 Thinking Skills paper, which was just recently released on the Department of Education website. So I'll go through and explain the questions, but before you watch any further, please have a go at the questions, right? Make sure you have completed the test under timed conditions, so do it in 40 minutes for the 40 questions. And make sure that you've completed and marked the entire exam as well, so you know which questions you got wrong. I've also tried to include timestamps at different points, so feel free to skip through to the specific questions that you just need some further clarification on. So I hope that this video is helpful, and also once I've gone through the questions in the paper, we will also do a debrief of the most common question types and some general advice for preparation. Okay, so without further ado, let's just get started. So we have our first question, which is a spatial reasoning question. One piece of a puzzle is shown below. Which one of the following shows a view of the piece from above? There's several different techniques with this, but the one I'm going to use is I'm going to look from above, right? And I'm noticing specific 2D shapes that I might see from above. So first of all, I'll see an L shape, right? I'll see an L shape here. So that means A won't work because there's no L. B and C and D are okay because you can see that particular L shape, right? Another 2D shape I'll see from the above view is this L. So I'll have to have an L there. So that means immediately C won't work because I don't have that L, and D won't work because I don't have that L, but B works because I can see the L here. Does that make sense? And then if you were to go further, you'll see another L like that from the above view, which is what you'll see here. And then you'll see a square, which is what you have here. Okay, does that make sense? So option B is clearly the correct option because the 2D shapes align. There are the 3 L's and the square that you'll see from above. Option B. So it's really a process of elimination where you slowly work through the different 2D shapes that you see. For example, the L in the most outer perimeter, leaving us to eliminate A, then that L, which we don't have in C or D, so obviously that just leaves us with B. And we can confirm that B works. Okay, let's go on to the next question. So we have question 2. Train journey from Jasper to Salumba stops at 4 other stations along the way. So when I read this, immediately I'm thinking, okay, I should draw a diagram, right? Jasper to Salumba with 4 stops along the way. So the way this diagram would look is, let me do it really quickly for you guys. So J for Jasper, S for Salumba, and 4 stops along the way. So stop 1, stop 2, stop 3, stop 4. Okay? So I can call them 1, 2, 3, 4. Alright, now it says Jennifer boarded the train at Jasper and got off at the second last station. So Jennifer got off at the second last station. So Jennifer got off at this station, right? Okay, and then it says Cavally station is between Wadi and Gadapul. Now we don't know where Wadi and Gadapul is, but where can Wadi and Gadapul be? Like, where are the possible locations? Well, if you think logically, we have Jasper at Salumba there. So if Cavally is between Wadi and Gadapul, then Wadi could be here, or Wadi could be here, right? Because then it could be Wadi, Cavally, Gadapul, or Wadi, Cavally, Gadapul. And then Gadapul could either be here or here. Now this is all tentative, we don't have enough information right now. And then as for Cavally could either be here or here. So again, not enough information, that's why we put a question mark. But it says the train stops at Wadi before Anja. Okay, stops at Wadi before Anja. So we can't have Wadi here because if Wadi was here, then that means Cavally has to be here, Gadi has to be here, but there's no space for Anja. So that means Wadi can't be there, okay? And it says the train stops at Anja before Gadapul. So Gadapul can't be here because if Gadapul was here, then it would be WKG and there would be no room for Anja to stop. So that means Gadapul has to be here, okay? So basically, Anja is either here or here. So right now we don't have enough information, but we know for sure that Wadi is station 1, Gadapul is station 4, and station 2, 3 is either Anja or Cavalli. We don't have enough information right now, but that's fine because the question is simply which station did Jennifer get off at? Well, Jennifer got off at station 4, which is Gatterpool, option D. Okay, moving on to question 3. Taller adults tend to have larger feet. Now the key word here is, or key words is tend to, which means usually but not always. Okay, that's really important to understand. Okay, so just because you're taller doesn't guarantee that you have larger feet. So this is not even a conditional statement. This is simply an observation pointing out a relationship, that taller adults tend to have larger feet. Okay, so we have a bunch of statements and we have to analyze whose reasoning is correct, right? The classic dialogue question that you might see. So Monroe says, your dad wears size 9 shoes and he's not as tall as my dad, so my dad's shoe size must be at least a size 10. So Monroe is making the assumption that if you're taller, you definitely have larger feet. But again, you have to remember, focus on the key words, which is tend to. So Monroe is wrong because Monroe used the phrase must be, assuming 100%. There's a difference between usually and something that is done with certainty. Must be signifies certainty, right? They're not the same, so Monroe is wrong. It's possible that Monroe's dad happens to be taller than Kevin's dad, but might have smaller feet, okay? So just because someone is taller does not guarantee that they will have larger feet. So Kevin says, no, that's not right. My dad's feet might be bigger than your dad's. That is correct. Because when we have tend to, remember the spectrum of probability, we have impossible, possible, right, and certainly. Tend to means usually. So it's also possible that the dad's feet still might be bigger than, Kevin's dad's feet might be bigger than Monroe's dad's feet, although he's not as tall. So who's correct? Kevin only. Okay. Question 4. Access to the meeting room for a secret club is only possible by answering 2 security questions. The questions are based on the following sentence. Only members will be allowed in. Each day, everyone is given a number, which is the starting position. When anyone arrives at the door, they're given 2 numbers and have to say the letters that appear in these numbers. Okay, so there's 2 numbers. There's actually 3 numbers that you get. The starting position, okay, so the first number, which is the starting position, and then the next 2 numbers, which is the letters that appear in those positions if counting starts at that day's starting position. Right, so first number is the starting position, and the other 2 numbers are the letter positions from that counting start. Today, the first person was given the numbers 4 and 8. So these are the second 2 numbers, right? And responded with the letters E and O. So the positions 4th position and 8th position correlate with E and O. So we want to find the starting position, okay? We want to find the starting position. So if we know that 4th and 8th positions give us E and O, based on this sentence, right, which is only members will be allowed in, what is the starting number? So where do we have E and where do we have O? Okay, so let's scour the sentence for the letters E and the letters O. So we have E here. So if that's position 4, position 5, 6, 7, 8, 8 would be R. So that won't make sense because we need 8th position to be O, right? We need 4th position to be E, 8th position to be O. So it can't be that E. Let's keep looking. What if this is the 4th position? So that's 4, that's 5, 6, 7, 8. That also won't work. So let's keep going. What if this one is E? E, so that's 4. Then that's 5. And that's 6, 7, 8. Bingo, that works, right? So we have E at the 4th position, O at the 8th position. So what's the starting position? The starting position, we just have to work backwards. So that's 3, 2, 1. Starting position is this L, right? So we have 1, 2, 3, 4, 5, 6, 7, 8. So now we have a second person who's given the numbers 3 and 10. So the person's given the numbers 3 and 10. So we know that the starting position is this L, which I'll highlight here. The first L. Sorry, I botched it. This L. So that's the starting position. So what letters should be given at the response? So that's position 1, position 2, position 3, which will be the B, and then position 10, well, that's position 8, that's position 9, that's position 10. Okay, does that make sense, guys? So let me just highlight for you guys. This is position 3, and this is position 10, right, from the starting position. So the answer is going to be option C, B, and E. Alright, moving on to question 5. So we have this question. A bird sanctuary has 4 parrots, Cliff, Echo, Muse, and Sky. Staff at the sanctuary are keeping track of the treats that the parrots like to eat. They have found if a parrot eats apples, it also eats carrots. If a parrot eats carrots, it also eats melons. No parrot that eats carrots also eats peas. So my approach to this question is to set up a Venn diagram. Okay, so we have several circles that we have to consider in the Venn diagram. Parrots that eat apples, and then those that eat carrots. Oops. Apples, carrots, melons, and peas. So let's set up the diagram. So first rule, if a parrot eats apples, then it also eats carrots. So apples goes here, carrots goes here. If a parrot eats carrots, it also eats melons. So then you can draw another circle, right? So if a parrot eats carrots, it also eats melons. So all those that eat carrots will eat melons. No parrot that eats carrots also eats peas. So there's no overlap between carrots and peas. So I'm going to draw another circle. This will be peas. Now, I don't know if there's any overlap between peas and melons. So maybe there's parrots that eat peas and also melons. We don't know if that overlap exists, so that's why there's a question mark in this intersection between peas and melons. But we know that there's no overlap between parrots that eat peas and parrots that eat carrots. So I draw a line here, and the line is simply an indicator that there is no overlap whatsoever between parrots that eat peas and parrots that eat carrots. Okay? Alright, so that's our Venn diagram. Based on the above information, which of the following must be true? So first of all, we have if Cliff eats peas, he also eats apples. Not necessarily. Actually, that's impossible, because if Cliff eats peas, right, if Cliff eats peas, then he can't eat apples. There's no overlap. So A is wrong. If Echo does not eat peas, he does not eat carrots. So if he does not eat peas, he could still eat carrots. That's wrong, because Echo could be here. What if Echo, right? What if Echo does not eat peas, but he does indeed eat carrots? So B is wrong. C, if Muse eats peas, she does not eat apples. So if Muse eats peas, Muse is here, right, in that category of peas. And basically no parrot that eat carrots can eat peas, and also all parrots who eat apples eat carrots. So basically, if Muse eats peas, she cannot eat apples. That is correct, right? Because peas can't intersect with carrots, and all parrots that eat apples eat carrots. Okay, so option C is our answer. Okay, question 6. Which of the following statements, if true, most strengthens the principal's argument? Okay, so what are we looking for? A way to strengthen the principal's argument the most. So whenever you have a strengthening, weakening argument question, the first step is to obviously work out, are you trying to strengthen, are you trying to weaken? Then you just have to understand how to break down the argument, which is simply premise, conclusions, right? Premises, conclusion. So find the main conclusion. The main conclusion is pretty easy to spot. It's literally that PE classes should include non-competitive sports and should not just focus on competitive sports like football and tennis. Okay? So PE classes should include non-competitive sports. That's the main conclusion, right? And what are the supporting premises? Well, one of the key supporting premises is that many students do not enjoy playing against their friends and classmates, as it often leads to unhealthy rivalries. So one of the reasons is that it's just a lack of enjoyment. Okay, so how do we strengthen the principal's argument that we should also integrate non-competitive sports such as bushwalking and dancing, and some other ones I can think of include maybe hiking or yoga into the PE curriculum. So let's go through the options. Option A, playing a competitive sport is a great way to learn the importance of teamwork. This is not strengthening because remember, we're trying to advocate for why non-competitive sports, so sports that don't involve competition, okay, should be included, okay. B, non-competitive sports are just as effective as competitive sports at improving fitness. Perfect, right? This does strengthen the argument. Now, we should always read all the options because we're trying to find the one that most strengthens. So sometimes there's options that might strengthen more than the other, even though there's several that strengthen. That's the possibility. So make sure you read every single option, okay? Now, option B certainly strengthens the principal's main argument, that kids should certainly have the opportunity to also participate in non-competitive sports, right? We shouldn't just force them into these competitions that can do more harm than good, such as generating unhealthy rivalries. And B points out that it's just as effective at improving fitness, which is pretty much the ultimate goal of sports. So why put kids under the unwarranted pressure or the undue harm of unhealthy rivalries, right? So B is very good at strengthening the argument. If we were to go through C and D, C is not relevant. C is just saying PE classes are compulsory, okay, but it doesn't really differentiate between why we should also include non-competitive sports, right? It doesn't differentiate between competitive versus non-competitive sports and why non-competitive sports may be favourable. So C is doing nothing to strengthen the argument. D, students like to have a range of different sports that they can choose to play. Again, range is really vague. You might think range is saying, oh yeah, competitive and non-competitive, but not really. Range is really vague. What does range mean? Does it mean a range of competitive sports? It's still not specifically advocating for the necessity of including non-competitive sports, right? For example, the Olympic Games have a range of sports, but they're all competitive. Swimming and basketball and all that jazz, those are all competitive sports. You can have a range of competitive sports. We want to talk about why non-competitive sports should be included. So that's why B is the best answer, because it is the most specific in supporting the principal's main conclusion. So always identify the main conclusion. It makes everything a whole lot easier. And also underline any keywords. In this instance, it would be non-competitive sports. Okay, question 7. So this one is actually pretty easy. I know it looks very intimidating because there's so much data going on, but if you just pause and think about what's going on, it's actually not that hard. So let's read this together. A street has a line of 5 houses next to each other on one side of the road. The 5 houses all have front doors that are painted a different color. A student looks at the houses from the opposite side. The student labels them according to the color of the front door and records which houses are to the left and which houses are to the right. So doesn't matter which row you choose, but if we just focus on perhaps the top row, houses to the left. So if we look at blue, there are 0 houses to the left of blue. So what does that mean? That means that the blue house is on the very left, okay? That means the blue house is on the very left. So if you actually want to set up a diagram, let's do it quickly. There's 5 houses, right? So 1, 2, 3, 4, 5, okay? So for the blue house, there's 0 houses to the left of the blue house. That means blue has to be on the very left. The red house only has the blue house to its left, so that means the red house is here. Then we have the yellow house, which has the blue and the red house to its left. That yellow goes here, and then you guys get the gist. Green house has blue, red, yellow to its left, so green is here, and pink has these houses. You only need 1 row, right? But you can just verify that your order is correct by checking with the second row, but that's not really necessary if you're short on time. We have blue house, which has the green, pink, red, yellow house to its right, yes. Green house, which has the pink house to its right, red, which has the... Okay, you guys get the gist, right? Just set up a diagram, and then you can easily answer this question. Which 2 houses are next to the yellow house? Well, it's just the red house and the green house. Done. Option D. Okay, question 8. So what is a mistake that John has made? Okay, mistake. Alright, so how do we work out the mistake? Well, let's read this together. Children at John's school were asked to complete a questionnaire about their sleeping habits to find out if they were getting enough sleep. The survey found that people who read a lot at bedtime slept fewer hours on average per night than people who didn't. So again, you have to be very careful about the wording here. So this is the survey finding. Now, if you guys understand anything about scientific studies, right, I don't want to make it too complicated, but just because you observe a relationship, it does not mean that one causes the other. Okay, so you might say, for example, a very common example of correlation versus causation is as ice cream sales rise, we found that shark attacks increased. So these were two directly observed trends which appeared proportional to each other, right? And you might say, oh, yep, so the ice cream sales must be causing the shark attacks, but in reality, it isn't. There's a third variable at play, which is summer, right? Summertime, people are going to the beaches, people are more likely to swim out in the ocean, so therefore the rising levels of shark attacks, and also more ice cream sales because people are buying ice cream. Anyway, I went on a tangent, but just know that just because you have an association, that does not mean there is causation, right? That does not mean that reading at bedtime causes poorer sleep, okay? So we see these two things occur together, but it doesn't mean one causes the other. So John says this shows that reading at night does not help you get to sleep. So John has made a causal fallacy because he's basically saw that this occurred, right? This relationship that was observed, and he goes off and falsely assumes causation when this could just simply be an accident, it could just be a coincidence, or there's other factors and variables at play. So what is the mistake that John has made? Let's go through the options. A, it could be that people are reading more because they're having trouble sleeping. Perfect, right? Because what John is saying is that reading, or bedtime reading, night leads to poorer sleep. But it could be people who are insomniac, people who find it difficult to fall asleep, who just lay in bed and have more time to read, right? So it could be the other way around. It's not necessarily that this causes this. It could be the other way around. Or it could be even a third variable leading to both, right? We don't know. So option A is very good because it points out that John has made a causal fallacy. He's assumed that reading causes poor sleep when we don't have enough proof to validate his claim. So A points out his mistake. If we go through B, C, D, they're not as good at actually pinpointing his mistakes. So B says it could be that people who don't read as much spend more time playing computer games. B is random. It just suddenly starts talking about computer games when that's not mentioned at all in the questionnaire. And we can't talk about any variables that weren't included in the study, right? C, it could be that some children are not allowed to stay up late reading books. Now that's actually not pointing out John's mistake. That's aligning with John's argument almost, because it's saying those who don't read at night, they don't stay up late, therefore they probably have better sleep than those who do read at night, who suffer with sleep problems. So C is not pointing out the mistake John has made, it's almost aligning with his statement, it's almost implicitly supporting what he's said. D, it could be that some books are more exciting to read than others. Again, it's not really pointing out the mistake, it's almost implying that John is correct because, hey, maybe these books are so riveting that kids can't fall asleep and therefore reading at nighttime does disturb sleep. So D does not point out John's mistake. You have to make sure that you're pointing out the mistake he has made. Okay, question 9. Each card in a set of 15 cards has one of 3 shapes in it: a triangle, square, a circle. Inside the shape, a number from 1 to 9 are written. No 2 cards are identical. The only number that appears in both a square and a circle is 7. Which of the following statements must be true? Key word here is must be. Okay, so there's several ways you can go about doing this. What I'm going to do is I'm going to set up a little table, and I'm just going to divide it into the different cards with square, triangle, and circle. So first of all, let's draw a little triangle here. So we have our triangle, then we have our square, and then we have our circle. Okay, so we know for sure that we will have a number. So actually, let's just read this rule. This rule is really important. The only number that appears in both a square and a circle is 7. Okay, actually, a square and a circle is 7. So that means that 7, right? We know that there's a square with 7 in it and there's a circle with 7. We also know, just to reiterate, that there are 15 cards. Okay, so that's important to note. Anyway, so that means that for all the other numbers from 1 to 9, we don't have any common numbers between the square and the circle. So we can't have 6, 6 or 5, 5 or 4, 4. That's not possible. So let's just go all the way back to 1 because we have numbers 1 to 9. Okay, so what if we have a 1 in the triangle? That means we can have maybe a 1 in the square, right? That's possible. This is just me testing some different combinations, okay? What if we had a 2 in the triangle? And we can't have a 1 in the circle because, again, the only number that appears in both square and circle is 7. So we can't have similarities between square and circle apart from the 7. So let's just say we have number 2. We can have a 2 perhaps in the circle. So I'm just guessing again, just trialing and error. 3, let's just say we have a 3 in this triangle. We can have a 3 in the square, right? That's possible. And then we can keep continuing down until we hit the total of 15 cards, okay? So we want to hit 15 cards in total. What if we had 4 in triangle? Maybe we have 4 in the circle. How many cards do we have so far? We have 2, 4, 6, 8, 10. 10 cards, so we need another 5 cards. What if we had 5 here? We might have 5 here. What if we had 6 here? We might have a 6 here, right? We just can't have any more similarities between square and circle. Okay, how many cards do we have so far? We have 14, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for the last card, we don't know where it would be. It could be, so let's just say the last card is 8, or it could be 9, it doesn't matter. It could be either here, here, or here. So, you know, we don't really have enough information, and this is all just quite tentative. Okay, so let's just go through this carefully. The key word here is must be true. So this is just one possible combination. We can also change around things a little bit, but we can kind of gauge that there's many cards in the triangle region, and that's primarily because we want to make sure we follow this rule that we can't have more than a 7 share between square and circle, okay? A, is it definitely true? No. Each shape appears on 5 cards. No, because here we have, for example, 7 triangles, and here we have 1, 2, 3, 4. Look. It's not definitely 5 for each shape. B, there are at least 5 cards with triangles. That's definitely true. That is 100% true because if you think about it, it's not possible to have less than 5 cards with triangles. Because if there's less than 5 cards with triangles, then that means there would be 11 cards given to square and circle. And that would not work because then we would have a contradiction of the rule where only one number appears in both square and circle 7. Right? As you can see, we have minimum 5 cards with triangle, so that must be our answer, option B. C and D are not definitely true. They're possibly true, but not definitely true. Let me show you why. C says there are at least 5 cards with squares. So here we have 1, 2, 3, 4. And what if we don't have the 8 here? What if we just have the 8 here? So if we had the 8 here, there would only be 4 cards with the square. And for here, there would also be 4 cards with the circle. So in this case, that disproves both C and D because it's possible for there to only be 4 cards with squares, 4 cards with circles, right? Or even less than that, respectively for both. So that just proves to us that C and D are not necessarily true. So the only answer that works is option B. Option B has to be true. And you can further experiment, right? But obviously, given we don't have a lot of time to do these questions, we should probably try to do the fastest way, which is what I've shown here. Okay, let's move on to question 10. So the way I've done question 10, and there's different ways, but what I've done is I will simply label the different zones. So I'm going to call the most center zone A, and then the one out B, C, and D, okay? So this one will be B, this one will be C, and this one will be D. So the one at the most outer zone is D, okay? This will just help us work out what's going on. Okay, so Zoe scores 8. So Zoe did 1 at A, 1 at C, and 1 at D. So we can say A plus C plus D equals 8. Right, Zoe scored 8. Bobby missed 1 and scored 4. So if you look at Bobby, we have A, B, C. So Bobby has 2 at zone C. So 2 at zone C. So 2C equals 4. Therefore, C equals 2. Okay, that's Bobby. Gabby is A plus 2B. And that gives you 11. Right? So what did Hermione score? So Hermione got B plus C plus D. So we have to work out the values of each respective zone. We already know that C equals 2, so we can replace C was 2, but we have to work out B and D. right? So let's work out B and D so we can work out what Hermione's total is. A key rule is the middle zone is worth the most points and each other zone is worth fewer points than the one inside it. So the middle zone is actually zone A. It's worth the most points, which makes sense. And then each zone is worth fewer than the ones inside. So as you go further out, it's worth less points. So we can come up with a formula that A is worth the most, right? Then followed by the next zone, B, then followed by C, and then followed by D. Now, if you were smart, you'd think, okay, so C equals 2. So if C equals 2, then what does D have to equal? Because as we know, D is less than 2, right? So zone D is less than zone C. So D must be 1, right? Has to be 1. Okay, so that's going to help us a lot because now we know that D equals 1, C equals 2. We can plug in these numbers into Zoe. So Zoe is A plus C plus D. So A plus 2 plus 1, which is equal to A plus 3, which is equal to what? Well, A equals 8 minus 3, which is 5. So now we know that A equals 5. And then we can plug that into the formula for Gabby. So instead of A, we can write 5. 5 plus 2b equals 11. So 2b equals 11 minus 5, which is equal to 6, right? So that equals 6. So therefore, B equals 3. So B equals 3. Okay, so these are the formulae that we've come up with. We worked out the values of everything. So now we can work out what Hermione got. Hermione got B plus C plus D. B is 3. D is 1. 3 plus 2 plus 1 equals 6. So what did Hermione score? Hermione scored a 6. Done. Okay, question 11. Jake and Robert are brothers. Their parents have told them they will not be allowed to go to the party tonight if they have not completed their homework. So this is a clear example of a conditional statement because we have the if. And the basic form of a conditional statement is if X, then Y. Okay? If X and Y. So if you're stuck, try to translate everything back to the basic conditional format. And then you can easily work out the contrapositive, which is basically the statement that you get by reversing and negating, which I'll show you in a second. And that is basically the same meaning as the original statement. So the contrapositive in this instance is if not Y, then not X. And if you are confused by that, let me show you why that's the case. This is just a very quick crash course on contrapositives. So if you are X, then you're Y. So if you're not in Y, so if you're not in that larger circle, which actually represents the necessary condition for being in the smaller circle, if you're not in the larger circle, then you can't be in the smaller circle. Does that make sense? Anyway, so what can we do for this? Jake and Robert are brothers. Their parents have told them they will not be allowed to go to the party if they have not completed their homework. So the format is, if they have not completed their homework, then they will not be allowed to go to the party tonight. So let's just write this out in the if X then Y format. If not completed homework, and this is not really grammatically correct, but just bear with me. If not completed homework, then not allowed to party. So you can also work out the contrapositive, which is when you reverse and negate. So you want to write it backwards and then do the opposite. So if allowed to party, then they have completed homework. Okay, so that's the contrapositive. Okay, so we just did a switcheroo between the two groups and then negated each. Okay, so this is what we have. This is just a more simplified version of what's going on. And you can even draw a Venn diagram. You don't need to do this in an exam, obviously. You only have 1 minute for the question, but I'm just doing it for the sake of explaining for you guys. So if you are allowed to party, so the smaller circle is always the sufficient condition first. So if allowed to party, to go to party, that is, then they have completed homework, okay? That's the larger circle, so that's the necessary condition. Does that make sense? So if you haven't completed your homework, so if you're not in that larger circle or the necessary condition, then you obviously can't be in the smaller circle, therefore you can't come to the party. Does that make sense? Okay, so that's our diagram, and let's go through and analyze different people's reasoning. So we have Natalie says Jake is coming to the party, but Robert is not. So Robert kind of completed his homework. That's not necessarily true, because what if Robert has completed his homework, but he's still not allowed to the party? Because being completing your homework is simply a necessary condition. It's not enough. Because maybe Robert has COVID, so Robert should be quarantining, right? That's why Robert still can't come to the party, although he has completed his homework, right? Maybe he's completed his homework, doesn't guarantee he will be allowed into the party. But Natalie says Jake is coming to the party. So if Jake was allowed to come to the party, he has definitely fulfilled that necessary condition. He's definitely completed his homework. So Natalie's wrong because Natalie says Robert can't have completed his homework. No, Robert may have completed his homework but still not being allowed to come to the party. But Daniel is correct. Jake must have completed his homework. Yes, right? Because if he was allowed, he must have done his homework. So only Daniel is correct. Option B. Okay. All right. We have this question. Some sets of 3-letter words can be ordered so that, and this is a problem-solving question where we have to analyze each rule. There's only one rule here, so that's pretty easy. No 2 consecutive words have any letters in common. So that means no word next to each other have common letters. Okay, so they can't have any of the same letters. For example, if you were to look at bog, does bog and cat have any of the same letters? No. Does cat and dog have any of the same letters? No. So cat does not have any similar letters to bog, nor does it have any similar letters to dog. Dog does not have any similar letters to cat, nor does it have any similar letters to met. Okay, consecutive just means next to. So words next to each other cannot have the same letters or common letters. Another such set of words is given below, but one word is missing. So we have a few issues. One word is missing and they're not in the right order. Okay, so this is pretty hard. We actually have a set of 5 words. Right now we only have 4 words, but one is missing. So we have a set of 5 words and they're not in the right order. Now, there's several ways you can go about solving this question. I'm just going to show you my way, but it's okay if you solved it a different way as well. The one thing I noticed straight away when I look at this is that many of the words have the letter A. Okay, so let me highlight that for you. Many of the words have the letter A. So of these words which have the letter A, because you can't have any words with letters in common next to each other, these words cannot be next to each other, right? So age, can, and pad cannot be next to each other. And we also know that they're 5 words. So if they're 5 words, right, 5 words, 5 positions, we know that these 3 words can't be next to each other. So therefore these 3 words must occupy these specific positions. The first, third, and fifth, they have to be separated, right? So age, can, pad, they have to be separated from each other because they can't be next to each other. And they all have A's, right? Does that make sense, guys? So I don't know the exact position of them, but we know also that cot has to be in either, let's choose a different color. Cot has to be in either the second or fourth positions. Okay, so cot has to be in either the second or fourth positions because that's just what's left for it. So you can experiment. You can say, let's just say we have cot here. Then that means the missing word has to be there. Okay, so let's just say we have cot here. We're just going to do trial and error. So let's go through option A. If cot was in position 2, then sud has to be in position 4. Now, is it possible to position the other words around cot and sud so that we follow this rule? Okay, so age. Where would age go? Age could go next to any of them, to be honest. Actually, let's choose which word would go in the middle, which doesn't share any similarities between cot and sud. So can age go here? Yeah. Can go here? No, it can't, because can shares a C. So can can't be next to cot. Can has to be all the way there. So age can go there. And then can pad go here? Yeah, perfect. We worked it out. So we know that option A works. Option A works, right? It's provided us with a viable sequence which has fulfilled this rule. And so we can move on. So just to recap, there's obviously different ways of solving this question. The one way I've used is I've just noticed that we have to separate these specific words because they all share an A. And because it's 5 words in the set, we have to therefore position them in positions 1, 3, or 5. That means position cot has to be in position 2, and the other word has to be in position 2 or 4. And then we did trial and error, and then we found out that this particular sequence works. Okay? Does that make sense, guys? So when you have a question like this, which is really finicky and there's a lot going on, try to look for patterns. I think the running theme with a lot of these questions in the selected paper is pattern recognition. If you're able to recognize patterns quickly, you can come across with almost a shortcut to solving these questions, because you really don't have a lot of time. You don't have a lot of time to be sitting through listing out all the possible combinations. Make sure you understand what's going on. Make sure you understand exactly the rule. So a tip is, in the exam, perhaps you can even underline the core rule and underline any conditions, just to orientate yourself with what's going on, okay? All right. Okay, question 13. In Ocean Town, there are 5 different coins, as is values. Okay, I'm just going to say A, B, C, D, E, okay? So this you can just solve algebraically. So 4A in 1B, 2B in 1C, 2C in 1D, 4D in 1E, and the question is, how many A's are there in 1E? So what you can do is you can just start substituting. So we know that 1E equals 4D. Now 1D equals 2C, so 4D equals quadruple of that, so you have to do 4 times 2C, which is equal to 8C. And then we also know that 1C equals 2B, so 8C is going to be equal to 8 times 2B. So 8 times 2B, which is equal to 16B. And then if you go to B, we have 1B equals 4A, so 16B equals 16 times 4A, which is equal to 64A. So the answer to our question, how many A's are there in 1E, is 64. Option C. Okay, which of the following statements, if true, most weakens Ying's argument? So again, find the main conclusion, right? Find the main conclusion, and it's pretty much right here. We should all buy soybean oil instead of palm oil for cooking. So soybean over palm for cooking. Okay, these are the key words you have to think about. And then you want to find out any supporting premises that Ying has provided in his argument. I found out that growing palm oil trees requires vast, so large areas of rainforest to be cut down. To help save the rainforest and animals that live in them, we must stop buying palm oil. So his main reason is that palm oils destroy habitats, palm oils require rainforests to be cut down. Okay, so what he's saying is he's proposing a solution which is soybean is better than palm oil for the environment and for protecting habitats. Now, how do we weaken his argument? How do we weaken his argument? Go through the options, okay? So A, palm oil is also used in bath products. That's not relevant. We're talking about cooking here, okay? So again, keep it within the frame of the passage. B, people are using less oil in cooking than they used to. Again, not relevant, because it's not really differentiating between soybean and palm, and it's not weakening his argument. Option C, growing soybeans also involves the destruction of rainforests. Perfect, because it actually shows us that Ying's suggestion backfires as it fails to achieve the main goal of saving rainforests and animal habitats, right? It actually backfires. So why would you preference soybean over palm oil? Makes no sense. So that very effectively weakens Ying's argument. Palm oil is more frequently listed in recipes than soybean oil. Again, that's very much not weakening, because you can easily argue against that and say, why don't we just substitute the palm oil with soybean oil in the recipes, right? It's not exactly targeting the core premise of the environmental impact of palm oil. So that's why D doesn't really do anything. C is the best option at weakening, because it's most relevant and most specific to the core premise, okay? So what's the main reason? Well, the main reason behind his argument is the environmental impact of palm oil. But hey, what if growing soybeans is just as bad as palm oil, right? That would sufficiently weaken his argument. All right, question 15. So this is a question which I think you can draw a Venn diagram for. So we have 3 activities: rollerblading, roller skating, ice skating. So I'm just going to use the abbreviations of RB for rollerblading, RS for roller skating, and IS for ice skating. So first of all, one thing I want you guys to pay attention to is skim this quickly, and it says here that anyone who can rollerblade can ice skate, and anyone who can ice skate can rollerblade. So notice how, oops, let me redo that. Okay, notice that this statement and this statement, they're both talking about the same two categories of rollerblade and ice skating. So basically, what we can assume from that is that the category of people who rollerblade is the same as the category of people who ice skate and vice versa. So we only actually need two circles. So the first circle would be those who can rollerblade and ice skate. Does that make sense? So this is just one circle, one entity, because everyone who can rollerblade can ice skate and everyone who can ice skate can rollerblade. So it's just one circle, right? There's no need for two circles, because if there were two separate circles, then that would imply that there's some people who can rollerblade who can't ice skate, or some people who can ice skate who can't rollerblade. So there's just one circle, okay, for the two statements in yellow. And then the next statement we have is anyone who can rollerblade can roller skate. Okay, so that's just everyone who can rollerblade can roller skate, so that's going to look like this. Okay, that's it. And then we don't have to worry about C. C is not really, well, C is relevant because it just shows that our diagram is correct. Not everyone who can roller skate can rollerblade. Yep, so our diagram is correct. There are people who can roller skate who can't rollerblade. Alright, so Shane has been ice skating for years. He will have no problem roller skating. Yes, because Shane, if Shane can ice skate, so he's in that smaller circle, he can definitely roller skate. Hannah is unable to rollerblade. She won't be able to roller skate. No, not necessarily, because maybe Hannah is here, where Hannah can't rollerblade, but maybe she can still roller skate. So Talia is wrong, because there's a possibility that Hannah could still be able to roller skate. Okay, so whose reasoning is correct? Way only. Alright, so this question looks very intimidating, but it's actually quite easy. You just have to go back to the core principle of understanding the rules. What are the rules? And I think there's only one rule, okay? So find the rule. So let's read this together. The string of symbols below contains only 4 symbols, dollar, and, at, and hashtag. What is the only one of these 4 symbols that can be added on the right-hand side of the string to ensure that, and the rule is as follows, there is no repetition of 3 consecutive symbols anywhere in the string. Okay, so what are we doing? We're adding a symbol. So we're adding one symbol on the right-hand side of the string, and we want no repetition of 3 consecutive symbols. So if we're adding a symbol here, then basically the 3 symbols that we're looking at will start with and, at, and something. So we don't want any repetition of a particular series of 3 symbols. So what you want to look for actually is, where do we have and at? Where do we have and at? Well, we have and at here. So we have and at hashtag, right? That's one of the 3 consecutive symbols. So we can't have a hashtag, because if we had a hashtag, that would mean that there was a repetition of the 3 consecutive symbols. So this can't be a hashtag. So we can eliminate option D. Where else do we have and at? Well, we have and at $sign. So that means this can't be a dollar, because if that was a $sign, again, there's a repetition. So we can eliminate the $sign. Where else do we have and at? We have and at, right? So we can't have at, right? We can't have at here. So we can eliminate option C. That means option B must be our answer. Done. That's all it is. Okay? So if we had and at, and there would be no other similar 3 consecutive symbols anywhere in the string. Okay, question 17. So this one is conditional reasoning once again, but we have a long-winded passage. It's very confusing. You might be thinking, what on earth is going on? It's not too difficult, but it's just a lot of information to deal with. So the key question is, which of the following is not possible? Okay, so let me just highlight that and let's break down exactly what's happening. So first of all, we have a series of logical statements, okay? So I'm going to underline them for you guys. The first one is this: her only chance of persuading her to come is if her brother, Sam, is playing in the school band. Okay, so what is this statement saying? It's saying that for Rhiannon to come, Sam must be playing in the school band. So this is a necessary condition. Sam playing in the school band is a necessary condition for Rhiannon to come. Does that make sense? So you can actually represent this in a little Venn diagram, which I'll do right here. So for Rhiannon to come, so let's just write Rhiannon or Rhi comes to school play. Okay, so that's a smaller circle. A necessary condition is that Sam plays in school band. Okay? Alright. Now, the problem is it's very hard to get accepted into the band since the standard is very high. Even some very talented musicians have been turned away. Okay, you need to really impress the music teacher at audition to stand a chance. So this is the next necessary condition. So how do we know it's a necessary condition? Because of the word need. So what's the necessary condition for Sam to play in the school band? Impressing the music teacher. So he needs to impress the music teacher to stand a chance. So if he does play at the school band, he has definitely impressed the music teacher. So we can actually draw a larger circle encapsulating Sam plays in school band, which represents the necessary condition being fulfilled of Sam impresses music teacher. Okay? Alright, so Sam does not practice hard enough to get to that kind of level. So you have to practice hard to be able to impress the music teacher. Okay, if you don't practice hard, there's no way that Sam could impress the music teacher. Alright, so which of the following is not possible? Again, reiterating not possible. So impossible, 100% not going to happen. A, Sam impresses the music teacher at audition but is not invited to join the school band. That's very possible because what if he impresses the music teacher, but the music teacher was like, there's still other people who are better than you, right? So he was not invited. That's still possible, as you can see based on this diagram. So this is possible. So A is not impossible. A is not the answer. B, Sam practices hard but does not impress the music teacher at audition. Very, very likely, because what if he just practices hard in the last few days? What if he practices really hard but not sufficiently to impress the music teacher? What if he just doesn't have the talent to impress the music teacher, right? There's so many things that are stopping him from being, from impressing the music teacher, right? Practicing hard is not enough to guarantee that he will impress the teacher. Sam does not impress the music teacher at audition, but Rhiannon still comes to the show. That's impossible. Why is it impossible? Because if Sam does not impress the music teacher at audition, that means he's not lying in that outer circle, so he's somewhere here, right? Sam is lying somewhere here. Then it's impossible for Rhiannon to come to the school play. Because for Rhiannon to come to the school play, there's actually two core necessary conditions. First one, Sam plays in school band, and second one, Sam impresses music teacher. So if Sam is lying all the way here, outside that circle, it's actually impossible for Rhiannon to come to the school play. Okay, so C is not possible, right? It's not possible that Rhiannon will still come to the school play. Sam is accepted into the band, but Rhiannon does not come to the show. Again, that is possible, because what if Rhiannon just doesn't feel like coming that day? What if she has other activities? What if she's caught COVID, right? There's so many things that might stop her from coming. Okay? Sam's acceptance into the band is only one of the necessary conditions for Rhiannon to come to the show. There's probably a few other ones that maybe has not been fulfilled. So D is possible, D is not the answer. Okay. Right, let's do this question. Scrub jays are a species of bird that will bury some of the nuts they collect in order to save some food for later. Scientists studying the species made an interesting discovery. So there's two conditions. First one, some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts the first time. It is only those scrub jays who have previously stolen nuts from other scrub jays that move their nuts. Okay, so what's going on? Basically, let's just write, let's first break down the second statement. It is only those scrub jays, so only those scrub jays who have previously stolen nuts from other scrub jays that move their nuts. So that means that if scrub jays moves their nuts, then we know for sure that they themselves have previously stolen nuts from other scrub jays. Okay, we know that for sure. So if they move their nuts, they themselves have previously stolen nuts from other scrub jays. Okay? And then if we go on to the the first statement, some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts for the first time. Okay. So, if see other scrub jays watching them bury nuts for the first time, they may. So this is actually quite interesting. It doesn't say or, it says some. So this is not really a conditional statement because it's not guaranteeing that the next course of action will definitely occur. It's not if X and Y, it's rather if X maybe Y, because here it's saying some. Some is the key word here. So they may move their nuts, but we don't know for sure. Okay, so let's just go through the statements. Logan, that means a scrub jay must be able to predict which other scrub jay will steal its nuts. No, that is incorrect because it doesn't say anywhere in the passage about the scrub jay's ability to predict who will steal its nuts, right? It never says anywhere must be able to predict, right? How can we know for sure? If Logan said they may be able to predict which other scrub jays will steal its nuts, that's probable because that can be a viable inference from the first statement. But Logan says must be able to predict, and there's no evidence whatsoever backing that claim up because must is very weighty. Must is saying 100% of the time scrub jays will know for sure if other scrub jays will steal its nuts. Never says anywhere that. Okay, so Logan is wrong. But Kimberly says if a scrub jay moves a nut it has buried, you can be sure it has had its nuts stolen before. Kimberly is also wrong because Kimberly has misinterpreted statement 2. Okay? If you read statement 2 carefully, and we've already broken down what's going on, scrub jays will move their nuts if they themselves are culpable. They themselves are, robbers who have stolen nuts themselves, right? You can't say they have had nuts stolen from them. No, it's the scrub jays who had previously stolen nuts themselves who move their nuts, right? So Kimberly has misinterpreted statement 2, so you have to be very precise when you're analysing the language, right? Especially in an exam when you're really nervous and you're trying to skim the passage. Make sure you're always precise, which is obviously challenging, but doing a lot of practice will help, and also underlying keywords would help as well. So both of them are wrong. Option D is our answer. Okay, let's go on to our next question. Question 19, problem solving. In a game called Splot, there are tokens that are worth 2 points, 5 points, or 10 points. I have one pile of 2-point tokens, one pile of 5-point tokens, and one pile of 10-point tokens. So that just means, each token is worth 2 points, whatever. Each pile contains the same number of tokens. So what I'm going to do is I'm going to give this number of tokens a value. Let's just call it n, which is the number of tokens in each pile. Okay, so we've got that. And then it says the combined total of 2 of the piles of tokens is 96 points. We'll come back to that. Let's just work out a formula for the value of the token. So for the 2-point tokens, we will have the number of tokens, which is n, times by 2 points. Okay, so that pile is going to have a value of 2n, or 2 times n. As for the pile of 5-point tokens, it's going to be 5 points times the number of tokens. And we're going to use n again because each pile has the same number of tokens. And n is just an arbitrary figure that we've given for the number of tokens in each pile. And then for 10 points, it's just 10n. So it says the combined total of 2 of the pile of tokens is 96 points. So, okay, we just have to guess and check which of the piles it could be. Could it be 2n and 5n? Well, 2n plus 5n is 7n. But 7n, could 7n equal 96? No, it can't, because 96 is not divisible by 7. So that won't work. What if we tried 2n and 10n? So those are the 2 piles, 2n and 10n. That's going to have a value of 12n, right? 12n. And can 12n equal 96? Yeah, because 96 is divisible by 12. And if we were to just double check the other option, there's only one more option, which is the 5n and 10n pile. So that's a combined value of 15n. 96 is not divisible by 15, so that won't work. So it must be, the 2 pile of tokens must be the 2-point and the 10-point, right? So that's going to have a total value of 12n. 12n equals 96, so n equals 96 divided by 12, which, as you guys should know, is 8. So that means there are 8 tokens in each pile, because we said n equals the number of tokens in each pile, that equals 8. So there are 8 tokens in each pile. So the question is, what is the total of the other pile of tokens? Well, the other pile of tokens is 5n. right, the 5-point tokens. And we know now that there are 8 tokens, right? So that's going to have a value of what? Well, 5-point tokens, 8 tokens, value of 5 times 8 points, which is 40 points. Therefore, B is our answer. Okay. Let's do question 20. So we want to weaken the argument. Again, when you do these questions, just work out the main conclusion first, okay? The main conclusion is pretty much in the first sentence here. Space exploration is a waste of time. Okay, and then let's try to work out the author's reasoning, how they've supported that central premise. When governments spend money on sending people into space, there's less to spend on helping people in need and on improving services for everyone. Scientists say that when they do experiments in space, they learn more about the universe, but their work would be more useful if it made life better here on Earth. So the main reason they've given is that the government is wasting money on space exploration, which, yes, it might help advancements in innovation in science, but it's not directly helping services and life here on Earth, okay? So basically they're saying that the government should probably spend more money on important things regarding life on Earth, such as maybe healthcare or transportation, instead of wasting allegedly lots and lots of money on space exploration. Because guess what? Rockets are very expensive, and training astronauts to go to space, that's also very expensive. How do we weaken this? Okay, how do we weaken this? Now, I just want to emphasize this part where they said government should spend money on things that actually improve life on Earth, implying that space exploration does not improve life on Earth. So let's go through the options. A, governments worldwide are increasing levels of education spending. That's not relevant, because still, this is about resource allocation and how the government is budgeting everything. If the government is spending, billions of dollars on space exploration, even though governments are increasing levels of education spending, maybe it's not enough to compensate on all the money that's spent sending people out to space. So A is not really relevant. A is not going to be weakening the argument. Option B, work by space scientists on aviation has increased the safety of flying. This does weaken. Why? Because it directly shows us that even though you're technically doing research and work in space, you're still improving life on Earth, because now we have perhaps more data on how to improve aviation safety, right? So that weakens the argument because it refutes this core premise that space exploration does not help life on Earth. It actually does, right? As shown by option B. Option C, the 1969 moon landing cost over $280 billion in today's money. Well, this is pretty much substantiating the claim that space exploration requires a lot of money, right? Money that might be better spent on other things. So that's not weakening, that's almost strengthening. D, experiments on plants in space have shown how we could grow them on other planets. Now, some kids might have been tricked by this option, right? Because they're listing an advantage of space exploration. But again, we have to remember the focus is on improving life on Earth, and knowing how to grow plants on other planets is not beneficial to life on Earth. So B is the best answer. Okay, B is the best answer for weakening the argument. Okay, question 21. At the start of the meeting, every member of the movie club gets one vote on the movie to be watched. Everyone must use their vote. The movie that gets the most votes is the one that is watched in that evening. This evening, there are 21 people at the meeting. So 21 people at the meeting and 5 movies to choose from. Kate, the movie that we watch will need to get at least 5 votes. Samira, if the movie gets 11 votes, we're definitely watching it. Okay, so how about we just say the movies are called A, B, C, D, E to represent the 5 movies, and there's 21 people, so there's 21 possible votes. Now let's just assume the most extreme scenario, which is that all the movies are pretty much similar in terms of their popularity, and therefore there's an equal or relatively equal distribution between the votes. So what's 21 divided by 5? That's 4 remainder 1. Okay, so let's just say that each movie has a minimum of 4 votes. Okay, 4 votes. Now, obviously, we still have one last vote, so let's just say movie A gets that one last vote, 5. That's basically the minimum number of votes required for that movie to win, for that movie to be touted overall the most popular, and for that movie to be the one chosen to be watched. Okay, so basically the movie that we will watch needs to get at least 5 votes. Kate is correct, because we just assumed the most extreme scenario, which I might repeat, is that all the movies are relatively similar in terms of popularity, and therefore there's a relatively similar distribution of votes between the movies. Okay? In that case, still, you need to have 5 votes minimum to guarantee that that movie is chosen. Samira, if a movie gets 11 votes, then we'll definitely be watching it. Samira is correct, because let's just say, again, I mean, it should be kind of obvious, but let's just say we choose A, and it gets 11 votes. So that means there's 10 votes left for the other movies, right? Now, again, the most extreme scenario, let's just say B gets 10 votes and the other movies get 0 votes. Still, that would guarantee that A would be chosen, right? Does that make sense? So this is the most extreme scenario, right? Okay, so Samira is correct. Both Kate and Samira are correct, option C. So what we've done here is we've assumed the most extreme scenarios. Okay, question 22, this one's a little bit challenging. We have a room measuring 3.2 meters by 3 meters to be tiled with a pattern tile like the one shown below. The tile is a square with side length of 0.25 meters. So this is the tile that we have to replicate over and over and over again in the room. So the tile has these dimensions. Okay, it's a square tile. And then we have a really, really large room, which obviously won't fit in this page, but let's just say it is like this big, and we're just trying to tile that room, okay? The room has dimensions 3.2 by 3 meters. So, first of all, you have to ask yourself, how many times will the tile fit along the width and also the length? Now, the width is just 3 meters and the length is 3.2 meters. Now, you can do several ways. You can work it out in several ways. You can convert the meters into centimeters. You can say that's just 320 centimeters, that's 300 centimeters, 25 centimeters, 25 centimeters, and then just divide, right? Alternatively, you could also just, I think we'll go down that route. But also tip is know that 0.25 meters is quarter of a meter. So how many quarter meters will fit into 3 meters? Do the math, guys. How many quarter meters will fit into 3 meters? 12, because 4 quarter meters will fit into 1 meter, and then 3 meters is triple of 1 meter, so 12, right? So this times 12 gives you that. That's a bit of quick maths if you're short on time, but I'll just show you guys the proper working out. So this is just 320 centimeters by 300 centimeters, and that's 25 centimeters by 25 centimeters. So you want to divide, okay? So how many times will 25 go into 300? Just do that division on a scrap piece of paper. Again, I don't think this is the most efficient way. I would just recommend thinking in terms of quarter meters and how many times that will fit into a meter. But if you were to do the division, you'll get 12, okay? So got that out of the way, 12. So this will fit 12 times. Okay, so 12 times along the width. So there'll be 12 of these tiles, these particular tiles, fitting along the width of the room. As for this one, 320 is actually not divisible by 25, right? Which is why they said the tiles are laid out from edge to edge, but the last line needs to be cut for it to fit, okay? Because there's a bit of a gap missing. So what's 320 divided by 25? Well, 320 divided by 25, think about it logically, guys. 25 times 12 gives you 300. So that means 25, the next multiple of 25 is 25 more than this, which is 325. So obviously if you do 320 divided by 25, you're going to get 12, remainder 20. Okay, just use your head. 320 is 20 more than 300, and 300 is a multiple of 25. So if you do 320 divided by 25, you're just going to get 12, remainder 20. So this is actually equal to 12, but there will be a remainder of 20. Okay, so that means, and this is the thing that you have to focus on. If you do 320, so if we're talking about the length of 320 centimeters, 320 centimeters divided by 25 centimeters will give you 12, remainder 20 centimeters. So there will be a remainder which is 20 centimeters. And that is basically going to be that last line. That last line that needs to be cut for it to fit in, the 20 centimeters. So what will that tile look like? So if we were to just convert all of this into centimeters, right? We want it to be 20 centimeters. 20 centimeters as a fraction of 25 centimeters is what? What is 20 centimeters as a fraction of 25 centimeters? 20 over 25 is equal to 4 over 5. Okay, 20 over 25 is equal to 4 over 5. So we basically want 4/5 of this tile, okay, to fit in. So that will actually look like what? Well, this has 1, 2, 3, 4, 5 squares, so 4/5 will look like this, okay? Does that make sense? So if you go from, let's use a different color. If you go from here to here, that's the 20 centimeters that is remaining. That's the 20 centimeters that we need to chop off so that we can fit the last 20 centimeters of that bit. Okay, so the answer is going to be option B, because we're taking essentially 4/5 of that tile. 4/5 of that tile. Comment down below if that makes sense. Okay. Question 23. Lauren wants to join her school's basketball team. To qualify, players must be at least 140 centimeters. So clearly this is just a necessary condition, right? Because we have the words must be, so must be necessary indicator. So all members of the basketball team are minimum b-ball team players are all at least 140 centimeters. Now Miriam is wrong because Miriam says Lauren was 139 centimeters last year, but she's grown to 141 centimeters, so she will definitely be chosen. Miriam has confused a necessary condition for sufficient condition. Just because you're at least 140 centimeters, that does not guarantee that you can be a basketball player. You can still be outside of that smaller circle, right? So remember, inner circle represents sufficient condition, outer circle represents necessary condition. Basically, if you're not in that outer circle, you can't be a basketball player, but just because you are in that outer circle doesn't mean that you're in the inner circle. Okay, so think about it. There's so many things that can still prevent Lauren from being on the basketball team. Maybe she's injured, maybe she's fractured her ankle, maybe she has some health condition stopping her from playing basketball. Okay, so Miriam is wrong. Best answer is going to be option C. Height might not be the only thing used to choose players for a basketball team, right? Maybe you actually have to have some athletic prowess. Maybe you actually have to know how to play basketball, right? What if Lauren doesn't know the rules of basketball? Okay, so there could be other conditions, other requirements for players to be on the basketball team. Okay, question 24. 3 switches are connected to a set of 4 lights. When a switch is changed, each of the light that it controls turns on if it was off, or off it was on. Okay, so we basically have red, green, blue, yellow lights. So let's do a bit of color coding. Whoops. Just bear with me, guys. So obviously when you're in an exam, you probably can't do that, so I will actually just go straight into a rough diagram. So we have red, green, blue, and yellow. And they're controlled by different switches. So switch 1 controls the red and green light, switch 2 controls the red, green, blue. Okay, so this is just the diagram that I would set up. Switch 3 controls the blue and yellow. Okay, so basically if you turn on one switch, it will turn the lights on or off. If all 3 switches are off, then all 4 lights are off. So let's just assume that all 3 switches are off right now. Which of the following is true? It is not possible to have all 4 lights on. That's false, because what if we turned on switch 1 and switch 3? If we turn on switch 1 and switch 3, then we'll have all the lights on, right? So option A is not correct. B, the blue light cannot be on when the yellow light is on. That's also false, because what if we just turn on light 3, right? That would turn on the blue and yellow. That makes no sense. Okay, so for option A, we can just turn on lights 1 plus light 3. For option B, we can turn on light 3. So these disprove these options. Option C, the green light cannot be on when the blue light is on. Again, that's false, because switch 2 can turn on green and blue. So that is false. What about option D? The red light cannot be on when the green light is off. That's correct, because red and green, they're both operated by light 1 or light 2, and there's no difference between them. So we can't just have red on, green off. That's impossible, right? They're either both on or both off, okay? So D is correct. Okay, I have just 4 cards. The cards have a letter printed on each side. The cards can be set out to make the following words. No letter appears twice on the cards. Which one of the following words could be made using the cards? So you have 4 cards, okay? So you have 4 cards. That's really important to take note of. Now, 4 cards, 2 faces, okay? So that means we'll have 4 pairs. Does that make sense? 4 pairs, because we have 4 cards, 2 sides on each. So to work out what's going on, let's work out the 4 pairs, okay? So the best way to approach this question is to actually compare the different sets of words and look for similarities and differences. So I'm going to compare these 2 sets first of all. So the similarity is C, okay, and A. So that means O, T, L, and K are different. So what's going on here? It could be O is on the same face as L, or O is on the same, same card. So it could be O is on the same card as L, or O is on the same card as K. We don't have enough information right now, but I'm just telling you the different possibilities. Alternatively, you could have T with L or T with K. We don't know right now. Okay, so let's look at some other cards for further clarification. What if we looked at L, A, C, K, and these? So if we were to compare these, we know that L would be either with S or O. Previously, we know that L is either with O or T. So if L is either with O or T based on this, and L is either with S or O based on this, then L must be with O. Okay, so I know that was a bit confusing, but I hope that makes sense. L must be with O, because if you were to compare this first of all, we already eliminated C, A, so just ignore that. So O is either with L or O is with K. Here we know L is either with O or T, right? L is either with O or T in terms of different sides of the same card. Based on comparing these 2 cards, we can eliminate C and K, so let's just ignore that. And we know that L is either with S or O, because we don't know if A is with S or O. But the common similarity between them is the O. So that means L must be with the O. Okay, L must be with the O. L must be with the O. Okay, so one of the pairs is L and O. So that's very helpful. Now, because we know L is with the O, and we were to compare these again, we know that T must be with the K, okay? Because L is with O, so L is with O, so that means we can cross out that one. So that means T is not with L, T is with K. Okay, and then we know L is with O. When we compare these 2, A must be with S, okay? And we know that A is with S, and also if you were to compare these 2, C must be with B. Okay, done. So these are the 4 cards. We'll have one card with L and O, another card with T and K, another card with A and S, and another card with B and C. So the question is, which of the following words could be made using the card? Can bats be made? No, because A and S are different sides of the same card, so we can't have A and S as separate letters. Can blot be made? No, because L and O are on the same card, right? Can cabs be made? No, because C and B are on the same card. Can cost be made? Yes, because we can have C, O, S, T. Perfect. Option D is our answer. Okay. All right. School excursion to watch a musical at the theatre is scheduled to take place next month. However, it will be cancelled if fewer than 20 students sign up for it. So this is just telling us the first condition we need, at least 20 students to sign up. Okay, so necessary condition 1, minimum 20 students. Okay, on top of that, even if 20 students or more sign up, there must be enough teachers to accompany them. Okay, so that's necessary condition number 2, which is enough teachers to accompany them, okay? And that would be specifically at least 1 per 10. okay, as per the school's policy. So let's go through the statements. Rohan, as long as 2 teachers are available to accompany the students, the excursion will still go ahead. He's wrong on so many levels. First of all, what if there's 40 students? Then you'll need 4 teachers, right? So we don't know how many students will sign up. What if there's an overwhelming number of students who've signed up, and still, if we had 2 teachers, that would not be sufficient, right? So that would mean necessary condition 2 fails. Also, Rohan is wrong because even if all these conditions were fulfilled, that's still not enough to guarantee that they'll go watch the school excursion. Sorry, they'll go watch the musical, because what if, I don't know, there's a COVID outbreak, or what if there's a protest on that day? You never know what's going to happen, right? And maybe there's some other necessary conditions which are not mentioned in this particular text box. Okay, so Rohan is wrong. Megan, if the excursion is cancelled, it must be because not enough students signed up for it. No, it could be because there were not enough teachers, right? Or it could be due to some other reasons that's not listed in this box. So Megan is also wrong. Whose reasoning is correct? Neither Rohan nor Megan. Okay, moving on. 4 students were comparing how much they enjoyed English, history, and maths. Okay, so let's first read the question, or the main question. What is the maximum number of students who could have liked maths the most? Okay, so we have 4 students. So let's start with Emily. Emily likes maths more than history. So could she like maths the most? Possibly, right? So let's just put a question mark here. I think it's likely. Okay. But we have to keep reading all the rules. Only Gemma liked English more than history. So, could Gemma like maths the most? Well, for Gemma, if she likes English more than history, right? Could she like maths the most? No, because if she likes maths the most, that would contradict the last rule that no one liked history the least. So Gemma can't like maths the most. Because she likes maths the most, that would contradict the last rule. So it must be the order of English, history, maths, or English, maths, history. But Gemma can't like maths the most. So Gemma does not like maths the most. Okay, M, yes, she can like maths the most. What about Wesley and Rohit? So Wesley and Rohit both like maths more than English. No one liked history the least. That's still possible for them to like maths the most, because let me show you. What if they liked, in this order, maths, history, and English? Right, so history is less popular than maths, more popular than English, but they both like maths more than English, and they don't like history the least, right? That's the key rule we have to follow. But yeah, it's possible that Wesley and Rohit like maths the most. So what is the maximum number of students who could have liked maths the most? Emily, Wesley, and Rohit, not Gemma. So 3 students maximum. Okay, 28. 5 keys are placed on a glass table. The image below shows the view of the table from above. So this one's a little bit tricky, but you have to understand what's going on and which view you're viewing from. So you're viewing from under the glass table. And the way you can orientate yourself is maybe focus on, just focus on one key first, because it's confusing if you focus on all of them at once. So I'm just going to focus on this key. Okay, so this key, where do I see this key in the options? Well, I see it there, 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 there. It looks to be the longest, and its blade is orientated almost horizontally to the length of the glass table, if that makes any sense. So what do you think is the view? The view is actually from, I know it's a bit confusing, but it's from, you're looking from there. Okay, so you're almost turning it upside down. You're turning upside down and you're viewing the bottom from upside down, that orientation. So, okay, this question is a bit overwhelming, but there's easy ways you can quickly work out the answer. First of all, just eliminate based on focusing on specific features. The first feature I notice is that this particular, I would like to call it, I don't know what they're called, notches, or the head. No, that's the head. Let's just call this the notches of the key. It's facing away from the main edge of the table. So we need the notches to be facing away from the edge of that table, the horizontal edge. So for A, that's fine. For B, that's fine. For C, that's fine. That's D, it's fine. But then you also have to say the notches are directed towards the width, okay? So it's pointing towards the width. So for A, that doesn't work because the notches are not pointing towards the width. It's actually pointing all the way towards that other side. So A doesn't work. For B, yes, the notches are pointing towards the width. C, yes, the notches are pointing towards the width, right? Which is what we want. But for D, the notches are pointing all the way towards the other side, so we can eliminate D. Now we're just left between B and C. And if you're really in a hurry, just look at the differences between B and C to save you time. So if you look at B and C, they're pretty similar, but the only difference really between them is that key. So let's focus on that key. Again, very simple. Just look at that key, orientate yourself. What is going on? Well, I would say the tip of the key is pointed towards the width. Okay, so the tip of the key has to be pointed towards the width, which we don't have in option C because rather it's the head of the key that's pointed towards the width, not the tip. We want the tip to be pointed towards the width, which is what we have in option B. Okay, so that's why C is not the answer, B is the answer. That's it. Okay, so I know these questions look very overwhelming, but all you have to do is hone in on small features and just eliminate based on that. Also, you can compare similarities and differences between the answer options themselves to save you time in an exam. Okay. All right. Question 29. When players are dropped from the school football team, it is usually, again, be careful, usually means sometimes, not always, because the coach thinks they have not been playing well enough. Sometimes a player will be dropped for not attending training every week. So there's two possible reasons why players could be dropped from the school football team: if they're not playing well enough, so they're not competent, and if they're not attending training every week. Okay, but there could also be other reasons why they're dropped, right? Maybe they have, I don't know, poor sportsmanship, maybe they're really rude, maybe they've harassed other members, or maybe they have some kind of personal injury, or maybe they have underlying health issues. There could be so many reasons, right? These are two possible explanations for why they're dropped. So knowing this, it should be pretty easy to answer this question. Kylie, the coach said she's going to drop Katya even though she's been playing well. She can't have been coming to all the weekly training sessions. Now, Kylie is wrong because Kylie fails to consider other possible explanations, which we talked about earlier, right? Kylie assumes there's only two possible explanations, so she's committed, well, what we like to call false dichotomy, assuming if it's not A, it must be B, failing to consider other options. So that's a very common fallacy in real life that people commit as well, having really black and white thinking there's only two possible explanations when there could be other ones. So Kylie's wrong. Fiona, if she came to the sessions and started playing even better, the coach definitely won't drop her. Again, she's wrong because we don't know why Katya was dropped, right? Maybe she had an injury, maybe she had a poor attitude, right? These are just possible reasons for dropping the player. And how do we know that once you've been dropped, you can redeem yourself and come back? What if there was a policy where once you've been dropped, you're never allowed to come back, right? So we can't say, oh yeah, if she started improving on these fronts, she'll definitely be accepted back into the school football team. We can't assume that, right? And always be careful of words like definitely or must or can't, because they are all words which assume certainty, right? And you should always just be a bit wary of them, okay? Because it's very easy to disprove these statements. In this case, both Kylie and Fiona are wrong. D. Okay, how do we weaken this argument? So again, you just have to find the main conclusion. The main conclusion is solid glass can actually be better described as a slow-moving liquid. And then the premises, well, the main premise is that the particles move just like in a regular liquid, and they're not fixed in an orderly structure. In glass, this movement is slow, so it cannot be detected during a person's lifetime or even over the course of several generations. Okay, and then one of the examples they've given to support this is medieval window glass, which has survived to the present day and is often found to be thicker at the bottom than at the top. So what they're saying is that if we had glass, the glass is flowing because it's apparently a slow-moving liquid, and therefore the bottom is thicker. So the bottom is thicker than the top. Okay, so this validates that glass is basically liquid, okay? So how do we weaken this argument? Well, we want to show that maybe this example that they've given is very, very flimsy. It doesn't actually prove anything. Maybe it's not that glass is flowing. Maybe it's just designed to be like that, right? Maybe medieval window glass just happens to be thicker at the bottom. Maybe it's not necessarily glass flowing that is causing the bottom to be thicker. Perhaps maybe the top is being eroded, or maybe there's some kind of rusting or some kind of weird chemical process happening that's causing this discrepancy between the top and bottom thickness. Or it could just be inherent to the design of medieval window glass. Okay, so we want to weaken the argument. Let's go through the options. A, glass can be melted, and melted glass, like every liquid, flows and obtains a shape. This strengthens, because this is pretty much further proving why glass is basically liquid. B, the human eye cannot detect tiny differences. Okay, well, they already repeated what's stated in the passage. They're not really weakening the argument, right? They've just repeated what's in the passage. So definitely not weakening the argument. C, modern buildings such as skyscrapers are often constructed of glass. That's just irrelevant. That's not telling us anything about if glass is like liquid. D, glass objects from ancient Egypt or Greece, which have remained untouched for millennia, so that's 1,000 years, are not thicker at the bottom than at the top. That's very good, because that shows us that not all glass are thicker at the bottom than at the top. So that kind of calls into question the validity of the example they've given here, right? Is it actually that glass is flowing? How do we know that, right? D is a very good option for weakening this argument. Alright, Alice is having some fun typing dates into her calendar. She types them in the format DD, so day, month, year. Okay, so 7th of March 1996. When she enters the date 12 February 2021, she notices it reads the same date when she turns it upside down. Okay, so, yeah, I think you guys know what 12th of February would look like. It would just look like that. And then if you were to turn it upside down, oh, okay, so try to basically reflect this. So if you were to reflect this upside down, I'm just going to use a different color, you'll get 1, and then the 2 reflects upside down will look the same. Okay? And after you reflect it upside down, you want to write it backwards. So that's what it would be when you turn the calculator upside down. First of all, a vertical reflection, and then you want to write it backwards. And when you write this backwards, it would still be the same because it's a palindrome. So there's 2 processes for working out what a date will look like when you turn the calculator upside down. Alternatively, this is probably very long-winded. I'm just going to finish this. As you can see, it's going to just look identical whatsoever. I think you should just write out the date and then turn the piece of paper upside down, okay? So, if we have option A, 19th of January, 10:06, that would just look like 19th of January, 10:06:1. Now, I don't know how to turn this upside down on the computer, but you guys can maybe turn your head 180 degrees and try to see what it looks like. It should also read 19:01, 10:06:1, okay? But if you want to do it manually, instead of turning the paper upside down, which I would advise because it would save a lot of time, the way you'll do it is what we've done here. 2-step process. First of all, reflect vertically, and then you have to write backwards. But that's just really long-winded, right? Because there's 2 steps. So, up to you. If you reflect vertically, you'll get, this is taking a long time, you'll get 16011091, and then after you write it backwards, you'll get 19011061, which is pretty much what we want. For the date to read the exact same as it was upside down. So A is our answer. Okay, just tell your head, or turn the paper. That's the easiest way to do it. Don't bother with this process that I've suggested. It takes a bit too long. I know some kids might have been tricked and they might have thought, oh, I have to find the palindrome. That's why they gave you the example 12th of February 2021, because they want to trick you. They want you to think, oh, it's just simply find the palindrome, but really it's actually about which one date will look the same when the calculator is turned upside down. So it's not just about palindromes, right? This is not a palindrome, but this will look identical when you turn the date upside down. Try it for yourself on a scrap piece of paper if you don't believe me, but yeah, that's how you solve this question, okay? Question 32. So for this one, draw a diagram. Okay, it's almost like a spatial reasoning question. So I always say when you have 6 people in a circle, just draw a circle and then just draw 3 lines. 3 lines like this to divide it into 6 equal sections. Okay, so the first person you put down in the circle doesn't really matter, but everyone else you have to be conscious of their position. So Grace is to the left of Catherine. So let's just say Catherine is here, then Grace is here, okay? So Grace is left of Catherine and is opposite of Willow. So Grace is opposite of Willow. So Willow has to be here. Max is facing Kari and is standing next to Catherine. So Max must be here because there's no more space next to Catherine. So Max is here next to Catherine and facing Kari. So Kari must be here. And that leaves us with Liam here. Okay? So they've been playing a game in which they throw a beanbag to one another in a specific pattern. So basically, it's firstly you throw to the person opposite and then you hand it to the left. Okay, so opposite, left, that's the pattern. In the first round, after 3 repetitions of this pattern, Willow is holding the beanbag. So Willow is holding the beanbag. Now, the question is, who was holding the beanbag at the start? So we know what happens after 3 rounds. So we have to actually work backwards. So how do we work backwards? Well, we have to do the reverse of opposite plus left. So that's going to be, you have to go right and opposite. Okay, so we want to reverse what's happening. So we want to do 3 repetitions. Okay, so to go backwards. So we want to go to the right, then opposite. So that's with Catherine. So that's 1 round. To the right and then opposite. So now it's with Kari. So that's the next round. And then we want to go to the right and then opposite, so now it's with Willow. So basically, who was holding the beanbag at the start? Willow, right? Willow. Okay, so back to where it started. All right, option C. So just work backwards. Do 3 rounds of giving it to the right person and then going opposite. Question 33. So what is a mistake Mr. Stead has made? Matt and Yash play chess together every day at lunch. They are at around the same level and they have each won around, so the key word here is around, half of the matches they played. Okay? So, Mr. Stead says, I can't remember how many games Matt and Yash played last week, but I know Matt won 5. So they must have played about 10 games. Well, the mistake obviously lies in the fact that he assumes that they have definitely won 10 games, assuming that they always win around half the matches they played. But this is around, so this is saying on average. There can sometimes be outliers, there can be discrepancies, there can be days where, or a week where one player just happens to be doing a lot better, right? Maybe Matt or Yash, they're fluking one week. So the mistake that Mr. Stead has made is assuming that a trend or what Matt and Yash win on average will always appear every week. Right? When there can be changes, there can be fluctuations in who wins and who loses. Okay. Right, this one is a code question. So Jody and Todd frequently message each other in code. They always use the same code in which each letter of the alphabet is represented by a unique symbol. Okay, so each letter of the alphabet is represented by a unique symbol. You have to make sure you understand what that means. That means that each letter has a different, unique means different, one of a kind symbol. So J will stand for something different to what O stands for and vice versa. Now, if we look at this code, right, compare, right? Code questions are all about similarities and differences. That's all you have to do. So if you look at the symbols in the code, none of them are the same as the symbols in their names, right? We don't have a triangle anywhere. We don't have a question mark anywhere. We don't have a hashtag anywhere. We don't have a greater than symbol anywhere. We don't have any of these symbols in their names. So that means that the favorite season, right, has none of the letters in the names of Jodie and Todd. So there's no J, there's no O, there's no D, there's no Y, and there's no T, right? So there's none of the letters in the names of Jodie and Todd. So immediately we can cross out several options. We know that there's no T, right? There can't be a T. So C doesn't work. There can't be a D. Sorry, there can't be winter because winter has a T and there's no T. So we're basically left between spring and summer. Now in summer, there's repeated M's, but we don't have repetition of symbol here that would correlate with repeated M's. So it can't be summer. So therefore it has to be spring. Done. See how easy that was? It's not hard. So just make sure you focus on similarities and differences. All right, question 35. The code to open a door in a computer game is a sequence of 4 pictures in a row. You have found the following clues about the code. The bell is next to the book. The apple is somewhere between the bell and the cat. The book is somewhere to the right of the cat. So, you have to choose one of 4 possible questions to ask. We basically have 3 rules so far, right? 1, 2, 3. We don't have enough information to work out exactly what the code is, so which one of the following questions would allow you to deduce the code? So let's just draw a diagram. So first of all, we have bells next to the book. That's really vague. We don't know if it's to the left or the right, so we'll come back to that. The apple is somewhere between the bell and the cat. Again, that's kind of vague. This one is useful to start with. So let's start with rule number 3, because we know how the book is positioned relative to the cat. So cat is here, book is somewhere to the right, okay? Somewhere to the right of the cat. And then we know the bell is next to the book. So the bell could either be here or here, right? It's next to the book. We don't know where it is. So how about we list out the possible combinations? We can have cat, then bell, book, or we can have cat and, I don't know, anything in between the cat and the book, and then book, bell. So the bell could either be to the left or to the right of the book, right? There's 2 possibilities. The bell is to the left or the right of the book, okay? So we've used up that rule. We've used up that rule. Apple is somewhere between the bell and the cat. So, okay. What are the possible combinations for apples between bell and cat? Well, for this one, it would be apple is here, right? So it's between the bell and the cat. And for this possibility, it would be that the apple's here. Because again, the book has to be right next to the bell, right? So the apple is between the bell and the cat, and the apple's here. So there's 2 possible combinations of the code based on these 3 rules so far, right? These 3 rules have basically led us to these 2 possible combinations. Now, we want to work out which combination is correct. Is it this one or is it this one? Now, what's the difference between these 2 combinations? Because we want to work out which question to ask to know for sure what the code is. Option A is the apple next to the book. Perfect, because if the apple is not next to the book, then it has to be this combo of cat, apple, bell, book. But if the apple is next to the book, then it has to be this combo. So if we were to ask that one question, right, is the apple next to the book, we will know which option to choose. Is it the first one or the second one? And that will allow us to deduce the code, the 4 sequences. Okay, so A is correct. Question 36. Although many birds are fiercely territorial, they're typically very sensitive when nesting. So territorial just means that you really care about the property or your territory. So they are very, very fierce about guarding their territory. So the land or the area or their place of habitance. They're typically very sensitive when nesting. If they feel their nest has been disturbed, they often abandon it altogether, even if the female has already laid her eggs. Now, this is not a conditional statement because they're not saying that X will definitely cause Y. They're just saying that X will often cause Y, which is abandonment. So disturbance of nest will often cause abandonment. Okay, so let's go through the different statements. We have Lorenzo. My dad accidentally disturbed a nest when he was cleaning the roof. So there's a good chance it may be disturbed now. Yes, because as we've worked out, if nest disturbed, often abandoned. Okay, so dad disturbed the nest, it's very likely that it is abandoned. We don't know for sure, but there's a good chance. So Lorenzo is correct. Katerina, there's an abandoned nest in the pomegranate tree in our garden that must have been disturbed. She's wrong because she's assuming that it was disturbed, but there could be other causes for abandonment, right? How do we know that disturbance of the nest has caused it to be abandoned? There could be other causes. So Katerina has committed the fallacy of assuming the cause when there's not sufficient evidence to validate her claim. Okay, so some other causes for abandonment of the nest could be maybe the parents themselves have some issue, right? Or maybe the eggs themselves are not viable, right? Maybe there's an issue with the eggs. There's so many possible reasons for why they might abandon the nest, not necessarily because it was disturbed. Okay, so Katerina is wrong because she said it must have been disturbed. It could be disturbed it could be disturbed, right? But how do we know it's definitely disturbed? So only Lorenzo is correct. Option A. Alright, question 37. 6 coins in our collection. There are 3 large coins, 3 small coins. For each size of coin, there's 1 coin with a circular hole in the middle, 1 with a square hole in the middle, and 1 with a star-shaped hole in the middle. Okay, so each coin is kept in a box, and all the boxes are the same size. Each box has 2 symbols. So there's 2 symbols. One symbol identifies the size, and the other one identifies the type of hole. Okay, so size could either be large or small, and type of hole could either be circular, star-shaped, or square. Okay, circular, star-shaped, or square. Right, so what they've done here is they've given us almost a code, right? Codes for the different features of the coins. So if it's large circular coin, circular hole, then it has omega and E. And then if it's small with a square hole, it has pentagon and triangle. Now again, the trick to doing this question is focusing on similarities and differences. We have a pentagon here. We also have a pentagon here. So pentagon, we don't know if pentagon stands for small or if pentagon stands for square, but we know that one of these features must exist in the third box. So this is either small or square, right? Pentagon means either small or square. So we have to have, at least one of these features in the boxes. So let's go through and eliminate any option which does not have a small or square feature. Okay, so this one has square, this one is large and star shaped. So that's not possible because we have a pentagon, and pentagon can either stand for small or square. We can't just have none of these 2 features. So B we can eliminate. C could work because it's small, and D could also work because it's small. So we're left with ACD. Now let's worry about the diamond. So do any of the symbols have diamond? No, there's no diamond in any of the symbols. So that means we can't have large and circular. Because large and circular, large is either the omega or the E. So because we have the diamond, it can't be large, right? It can't be large and it can't be circular because we don't have the diamond in anything representing, any of the symbols representing large and circular. So because it can't be large and circular, we can eliminate A because A has large, which won't work. And we can eliminate C because C has circular, which also won't work, right? So that leaves us with D. D must be our answer. So this was simply solved through a process of elimination. That's all it is, okay? All right, question 38. What is a mistake Chloe has made? In an athletics competition, there are 4 heats, and every participant runs in 2 of the heats. The finalists are all of the participants who finished in the top 2. So this is a rule here, finished in the top 2 in at least one of the heats. So there are 2 heats, and that's the key thing. Well, there's 4 heats, but every participant runs in 2 heats. So what is a mistake Chloe has made? Chloe says Tim was faster than Leon in the first heat. So if Leon qualifies for the final, so will Tim. Not necessarily, because what if Leon qualified based on a different heat, right? So let's just say first heat. Let's just say hypothetically we have we have Jen, we have Steve, and then we have Tim and Leon. So basically, Tim and Leon, they're not in the top 2, so they don't qualify. And then maybe in the second heat, we have Leon qualify, right? But if we don't have Tim anywhere in the top 2 for any of the 2 heats, then there's no way that he'll qualify. So what is a mistake Chloe has made? Chloe has failed to account for the possibility that Leon might have qualified based on his performance in his other heat. So yeah, maybe Tim beat Leon, but maybe Leon didn't qualify based on his position in the first heat. Maybe Leon qualified because he came in the top 2 in a different heat, right? The rule is that you have to finish in the top 2 in at least one of the heats. How do we know that Tim has finished in the top 2? We don't, right? There's nothing here that warrants that Tim would have finished in the top 2 in any of the heats, so therefore we can't conclude this to be true, that Tim will definitely qualify for the final. So C is our best answer. Okay, for this question, there's several ways you can go about solving this. This is a logic game question, so let's set up a diagram. Let's quickly set up a diagram. So just bear with me for a while. Try to get through this quickly. Hopefully you guys can be a bit more speedy than I am. Oops. Okay, so I'm going to set up a diagram where I'll have the 4 activities listed, which is fishing, reading, playing the piano, and drawing. And then I'll also have the 4 people. So that's P, that's Q, that's R, S, and T. Okay, cool. And I'm just going to separate those. And then in terms of the eye color, so obviously they have either blue or brown eyes. Different ways. I'm going to use this as blue and a different color to represent brown. But obviously when you guys are doing an exam, you don't have as much liberty and time to set up diagrams like that, but I'm just doing it for the sake of helping you guys. Okay, so, right. Okay, so P likes reading and fishing. So immediately I'm just going to put a tick for reading and fishing. And remember the rule, they like 2 of the following activities. Okay, so they like 2 of the following activities. That means that P does not like piano and P does not like drawing. Q likes playing the piano and fishing. So piano, fishing, right? So that means he does not like the other 2 activities. S likes drawing. Okay. And then the last 2 rules is where the trick to answering this question lies. Okay, this one's a little bit hard, so just bear with me. But the last 2 rules states everyone likes fishing except one person with blue eyes. We'll come back to that in a sec. Everyone with brown eyes like reading. Okay, so this is a bit confusing, but think about it like this. If you don't have brown eyes, then you don't like reading. Sorry, no, let me rephrase that. If you don't like reading, then you can't possibly have brown eyes. Does that make sense? Because everyone with brown eyes like reading. In other words, if brown eyes, like reading. So if not like reading, then not brown eyes, therefore blue eyes. So if you don't like reading, then you have blue eyes. That's why if we look at P, now P might have blue eyes still, because P likes reading, but it doesn't mean that if you like reading, you have brown eyes. It just means that if you have brown eyes, you like reading. So P possibly has blue eyes, brown eyes, we don't know. But for Q, we know for sure that Q cannot have brown eyes because Q does not like reading. Q does not like reading. And everyone with brown eyes like reading. So Q has to have blue eyes. Okay, so Q has blue eyes. Now, this makes option B look, half promising because we already have half of it correct. A, there are more people with brown than blue eyes. So that means that there's going to be 3 or 4 brown-eyed people compared to 1 or 2 blue-eyed people. Now, this is a little bit hard to gauge from such limited information because obviously, as you can see, we don't have a lot of information. We can't even complete this whole diagram. But that's okay. Let's just look at the next rule. Everyone likes fishing except one person with blue eyes. Okay, so everyone likes fishing except one person with blue eyes. Now, look at S. S is where it gets interesting. Let's try to work out if S has blue or brown eyes. So what you have to do is you want to test out the different possibilities. So if S has brown eyes, is that possible? If S has brown eyes, right, everyone with brown eyes like reading, so that means S has to have reading, S has to like reading and drawing. But that's not possible because it says everyone likes fishing except one person with blue eyes. So it's not possible for us to have a circumstance where someone with brown eyes doesn't like fishing, right? That wouldn't work. So S can't have brown eyes, because if S had brown eyes, then S would like reading, and we also know already that S likes drawing. So these are the two activities fulfilled, and that just means that we would have someone with brown eyes who does not like fishing, but that would contradict this rule that everyone likes fishing except one person with blue eyes. So it's not possible for S to have brown eyes, so therefore S must have blue eyes. Does that make sense? So S must have blue eyes. Okay, and that's pretty much all we can gauge. We don't even know which activities are and S and T exactly. Oh, sorry, we know that S likes fishing. Or S doesn't like fishing, right? So S doesn't like fishing, so S just likes reading or piano, right? That's all we have, right? And that's enough to answer this question. So the trick with logic game questions is make sure you understand the rules and also understand that you don't necessarily have to complete a diagram. Here we have an incomplete diagram, but through a process of elimination and through thinking of negatives of, circumstances that cannot exist, we can come to the conclusion that S has blue eyes and Q has blue eyes. Now, these were all arrived at actually finding the opposite of this statement, or not the opposite, the contrapositive, which is that if you don't like reading, you don't have brown eyes, so therefore you have blue eyes. So you always have to be conscious that when you don't have a lot of information, sometimes you have to work through elimination, work through a process of exclusion, okay? I hope that makes sense. This is a pretty hard question. Okay, let's go on to question 40. So this one, for this one, you guys probably have read this already. So the way I would approach it is setting up a Venn diagram. So we have three core categories, beanies, scarves, and gloves. So I'm going to set up a Venn diagram with three circles, okay, to represent the three different categories. So we have beanies, scarves, and gloves, okay? I'm just gonna label them. So this one's beanies, this one's scarves, this one's gloves, and this outer region represents those who don't wear beanies, scarves, nor gloves. Okay, so 15 were wearing beanies. Now, what does that mean? What does 15 were wearing beanies mean? It means that everything in that circle adds up to 15. So that means this region plus this region plus this region plus this region gives you 15. And then 8 were wearing scarves, so that means that everything, like every section in the S or the circle of scarves adds up to 8, and so on for gloves, okay? So just understand what you're getting yourself into when you set up these diagrams. You can't always put down values immediately. We're actually going to use these numbers at the end. On close inspection, he could see that all of the children wearing scarves were also wearing gloves. So what that means is that this region here is equal to 0. Why? Because there's no students who are only wearing scarves and not wearing gloves. So this region here is equal to 0, and also this region here is equal to 0, because there are no children who are wearing scarves but not gloves. So if you're wearing scarves, you're definitely wearing gloves, right? So all of the children wearing scarves were wearing gloves, so there's no region which is in scarves which doesn't overlap with gloves, right? Half of the children with a scarf also had a beanie. So how many children had scarves? 8. So half of 8 is 4. So 4 children with a scarf had a beanie. So how many children in the overlap between scarf and beanie? 4. Okay, so that's 4. Does that make sense? Okay. There were 4 children wearing a beanie who also had gloves but no scarf. So beanie and gloves but no scarf. So that means 4 children in this region, right? Beanies and gloves but no scarf. There were 2 children with no beanie, no scarf, and no gloves. So 2 children there. Now, you might be thinking, okay, what goes here? and what goes here and what goes here, that's where you have to come in and use these values. So first of all, with 15, we're wearing beanies. That means all the numbers in this circle add up to 15. So right now we have 4 plus 4, that gives us 8. So that means that has to be 7. Okay, does that make sense? Because now we have everything in that B circle, that beanie circle, 7 plus 4 plus 4 give you 15. Then we can use the next value of 8, we're wearing scarves. So that means there's 8 in that scarves circle. So that's 4. That must be equal to 4. Okay, so that will add up to 8. And then we have 12, we're wearing gloves, so 12 in the glove circle. Now I already have 4 plus 4 plus 4 equals 12, so that just means that there's 0 students who are just only wearing gloves. Okay, now the final question is simply, how many children arrived for class yesterday? Well, how many, like this whole rectangle and the 3 circles represent the total number of children in Freetown, so you just have to add up the numbers. So you want to do 2 plus 7 plus 4 plus 4 plus 4. Okay, 2 plus 7 plus 4 plus 4 plus 4. You don't have to add the zeros. And you're going to get a final answer of 21. Comment down below if that makes sense. I hope this was helpful. Setting up a good diagram really helps you with solving a question like this. And I think also doing a large volume of these Venn diagram type questions is really helpful. But yeah, it's just a matter of practice, and you can certainly work on these question types and improve. Okay, so don't stress. So overall, this was a pretty challenging exam. What I'm going to do now is I'm going to debrief the question types in the thinking skills paper and also give you some general tips that you can use in your preparation. So first of all, these are the general question types in thinking skills, and this was based on the Cambridge Assessment syllabus. And largely you can say that there's problem solving and critical reasoning questions. So on the left-hand side, these are the subcategories of problem-solving questions, right? Things like data analysis, mixed problem-solving, spatial reasoning, logic games, and also critical reasoning questions involving assessing truth and validity of arguments. So those are all the dialogue questions that you saw. Reasoning errors, so finding the mistake in someone's reasoning. Inference and logical deduction, so questions which are like, which of the following must be true, which of the following is not true, etc. And strengthening and weakening arguments. So these are the core critical reasoning question types that you would likely see. But keep in mind, the thinking skills paper is constantly evolving, and I guess the New South Wales Department of Education wants to make the test a lot less predictable, which is why this year we actually saw some changes compared to the previous years. So I'll talk about that in a moment, and you guys can obviously come back to this. I won't elaborate too much because I think everyone's already quite familiar with what critical reasoning involves. So this is a breakdown of the 2022 thinking skills paper. So this is how I broke it down, but of course you can categorize questions differently. It's all good. But this is a very rough breakdown, around 50-50 distribution between critical reasoning and problem solving. So 18 questions in critical reasoning, 22 in problem solving. In terms of dialogue questions, so the questions where we have 2 people talking and interpreting these box statements, those were very common. There were 8, right? So that's 8 out of the 40 questions. So that just requires a very good understanding of even just identifying logical fallacies, identifying chains of reasoning, gaps in reasoning, knowing how to find the contrapositive of logical statements, knowing the difference between always, must, never, often, like all these different modalities. That's very helpful, and being very precise in your analysis. Okay, so yeah, that's what's going to help you get these questions correct, and doing a lot of practice. Logical deduction, so again, they're all kind of similar, but logical deduction, by that I just mean which of the following must be true, right? So I would have categorized them by these labels as we've gone through the paper. So for example, this question, which of the following is not possible? That's a logical deduction question. Strengthening, weakening arguments, right, you guys know the gist. Detecting the reasoning error, there were 4 questions there. Okay, so that's the distribution for critical reasoning. And in terms of problem solving, there were 4 spatial reasoning questions, so that's quite important. 13 finding procedures. Now, finding procedures is just an umbrella term I use for general problem solving questions. Also, just some good resources in a moment, but I guess the consensus from the 2022 paper from our students was that there were a lot of difficult problem-solving questions, and really exposure to a wide range of questions is the best way to prepare. You can't really predict the exact finding procedures questions that you'll get next year. So yeah, the only solution is lots of practice and also being able to think on your feet. The best way to work on these questions is really just exposure to a wide range of question types, as there's no real way of predicting what will appear next year. Okay, so I'll talk about some resources in a moment. There were logic game questions as well, and those are very long-winded, but I think, again, lots of practice and doing the practice in time-pressured conditions, because you only have 1 minute per question. And I think whilst these questions can appear overwhelming and like there's a lot of information, a key skill is knowing where to hone in, knowing which rules to focus on, and also being able to develop the ability to triage these questions. So sometimes you'll come across a question and you'll think, oh, this is very hard, and you might spend precious minutes, right? But exam technique means you know when to move on, you know when to mark the question to come back to later. Okay, so I'll talk about that in a moment as well. There were some codes and cipher questions, 3. So this was the overall distribution. In terms of general comments, there were no graph or data analysis questions, so none of the relevant selection or finding similarity questions. And there was a great emphasis on logic games and problem-solving questions. There were some new coding and cipher questions added. So the consensus is basically question types that will appear is quite unpredictable, but practice really helps. And time management and exam technique is crucial. It's the most important thing, especially when you have very, very limited time. Okay, so as I said earlier, there was a huge focus on general problem solving, logic games. So I'll talk about some tips to improve in that section. Volume and practice, right? I know it sounds really simple, but you have to do as many questions as possible. Volume helps a lot. And the only way to improve is actively trying these questions and trying to spot different patterns, right? Looking for similarities and differences, and forcing your mind to rapidly work through inferences. Timing is everything. You only have 1 minute. And remember, the test is designed to be solvable in the 40 minutes, right? They designed it for year 6 kids, so it's achievable, but it's hard, but it is doable, okay? So make sure you focus on specific techniques, construct simple, easy to interpret diagrams, right? Use shorthand, for example, R instead of Raymond. Just practice drawing diagrams that make sense to you. And do them fast, right? Just make sure you understand you have very limited time. If you're taking your time and all, dawdling around, you're going to run out of time. You might end up missing 5, 10, 15 questions, and that's not good, okay? So make sure you work fast. Never jump to assumptions, so if necessary, create several diagrams, okay? So if you're working on a logic game question, don't be like, oh, my gut instinct is that I think Raymond likes fishing, so I'm going to put that there. No. Create several diagrams to account for the different possibilities. Common exam traps. So poor time management is the biggest mistake or trap that kids fall for, especially when they get overwhelmed. They go into mental hijack. They start thinking and spending a lot of time on certain questions, right? If you see a question that's hard, move on, okay? And come back to it later. Always mark it, come back to it later. Allocating excess amounts of time for easy questions, right? You have to work fast. You want to aim, and I know this might not be possible, you want to aim for 5 minutes left to check the questions in the end. This might not be possible, but that should be a pretty good goal, okay? Spending too much time on certain questions, and not looking for the fastest, easiest route. Now, my tip for this is always go to the question stem first, and then quickly skim over the options, because then at least you know what you're getting yourself into. Okay, so for example, if I had this question, right, I'll just quickly read the question stem, which is not possible, and then I'll skim all of this, and this is clearly about, a conditional logic chain. If I had, for example, this question, I'll just quickly read the question stem. I know this is about weakening the argument, so I know which process to undertake, right? Find the conclusions, find the premise. Okay, decoys. So not being able to spot common decoys and traps. not being able to filter out irrelevant details, jumping to conclusions, failing to consider all components of the question, relying on your gut instinct, choosing options which feels right rather than using tactical elimination. If you're short on time, it's okay if you can just eliminate 2 options and then choose maybe the other 2 remaining options. You have a 50-50 chance of getting it right, but if you're simply going by your gut feeling and not actually working through things systematically, then you're bound to get the question wrong, okay? Some useful resources. So I would highly recommend that you make sure you understand every single question, I must say, in the sample paper and the 2021-2022 papers on the New South Wales Department of Education website. You can also Google Cambridge A-Level Thinking Skills paper 9694. So you just type that into Google, you'll have a whole bunch of websites come up and you have pretty much open access to these papers. I will say that some of the questions are a little bit difficult, but I think it doesn't hurt to tackle these questions. Just because the test could be progressively getting more and more difficult. We already have seen that the 2022 paper was more difficult than the 2021 paper. So having a go at these questions, some of these questions won't hurt. And also TSA Oxford past papers, again, you can just Google them. I think the main thing I want to point out is that, especially for problem-solving questions, it's hard to predict the question types. I know critical reasoning is a bit more clear-cut because we've already seen the dialogue questions, the strength and weaken questions, the mistake questions. So if you do a lot of practice there, your skills will certainly develop. But for the problem-solving questions, I think exposure to a lot of different, so a wide variety of question types is what's going to help you the most. Anyway, and I think doing mock trial tests, simulated test conditions is super useful, because if you are not used to the stress that comes with sitting the test, then you're not able to perform optimally. A bit of stress is good. It's known as eustress, and that will help you, that will give you the adrenaline rush to think fast, think quick, and get pumped to work through these questions. But too much stress is also not good, because then you start freaking out. You go into mental hijack. So how do you combat this? How do you prevent really high levels of stress? The right preparation, okay? And that means doing exams under time pressured conditions. So try to find opportunities to do trial tests. If you get any work, if you find any resources, try to do them under timed conditions, okay? And also compete with yourself. You still have several months, so you guys have several months until the selective schools test, so there's a lot of time to improve. Try to do better than you did yesterday. Remember, taking small steps consistently will help you achieve your goal. So just do regular practice, fix your mistakes, work hard, and you guys have got it. So thank you so much for tuning in. I hope this was helpful. Leave me a like if it was, and I wish you guys all the best in your studies. Keep hustling. Bye bye.